Okay, so when we look at a problem like this, where we've got equations that can be built, scenario that can be written, we want to make sure we're reading it carefully and trying to look for things like, we're basing this on the equation y equals mx plus b, where m represents the growth or the slope, or what's changing each time, and b represents a y-intercept, or a starting point. Basically something that's fixed and constant, but this is the one that'll be changing over the course of time. So when we read this, answering the following question by writing a pair of equations and solving them. John's bamboo tree is 25 feet tall. Okay, that's what we know about it right now, but it's growing at a rate of 2 feet per year. We're looking for words like growing, which means it's changing over the course of time. This is the rate. Whenever it says it's changing, and the word rate, 2 feet for every year, there's two things going on right there. There's 2 feet are added to the tree for every year that goes by. Okay, that's showing growth. That's showing growth over time. Okay, so if we understand that 25 feet is where it's at right now, and every year it's going to gain 2 feet, this is our starting point. Okay, now we might say, well, it's not starting. It's already been growing for a number of years because it's already 25 feet tall. That's true, but it's where the problem is having it start, and from that 25 feet, it's going to gain 2 feet per year. You can almost think of it in terms of a 2 over 1, as we normally do with the slope. The 2 is the number of feet, and 1 represents the number of years. So 2 feet for every year that goes by, starting at 25. Okay, that's the bamboo equation because it says bamboo tree. Now, the pine tree is 1 foot tall. It's much smaller, but it grows at a rate of 10 feet per year. I don't know that the numbers are very accurate because bamboo is like weeds. It grows so fast. But anyway, that's okay. We got a 1 foot tall pine tree, and it's growing at 10 feet per year. Anyway, it's only 1 feet tall. That's the starting amount. Sometimes I'll see people put a 1 here just because it's a smaller number, and they're used to seeing a bigger number. It's here, but this is growing at 10 feet per year. That's growth, and that's where that goes. So we have two equations, y equals and y equals. Sounds like the equal values method to me if they should ever ask us to solve this thing, right? Well, lo and behold, after what year will the trees be the same height? That's basically asking, when we're talking same height, that's the y variable, okay? This is an equation to predict height based on growth over time added to a starting amount, okay? So when will they be the same height, and after what year? So it's basically saying solve for x, or solve for x, because that x represents the number of years. And we'll do that by setting them equal to each other. So we have 2x plus 25 is eventually going to be equal to 10x plus 1. We're going to solve for x. We want to get x by itself, so let's move the x's to the same side. We'll subtract 2x from both sides. You may move the 10 over and have negative numbers. That's okay. I got a 25 here, I got an 8x over here, and a plus 1. So now that I've got the x's on one side, let's move the other stuff to the other side. That 1 is in the way. So we got 8x is equal to 24. Now, to get x by itself now, it's connected a little bit more strongly than the plus 1 on the outside. It's connected by multiplication. So the opposite of that would be division. So we're going to divide both sides by 8. And I come up with an x that's equal to 3. Now, if x equals 3, let's think about what that's referring to again. It says after what year, and when this is 2 feet per year, 10 feet per year, this is the number of years that they'll be the same height. So after what year, this would be year 3. Okay, that's the answer. But the question about how tall are they in 3 years, how tall are trees when they're the same height? Well, remember, we're ultimately solving for something that's an x and a y, okay? And all we have so far is the x. So we know what that is. We don't know what this is yet. Okay, yeah, we can still see that. Sorry about that. So we're looking for the y value. The nice thing is we happen to have two equations where we can plug y into it and say, okay, well, I can plug x into here. 10 times 3 is 30 plus 1 is 31. Or I can go over here and I can plug it into this one. In fact, let's write it down. 2 times 3 plus 25, that's a 6 plus 25, which is the same 31 that we kind of did in our heads over here. So how tall are they? They're 31 feet.